Hi everyone, welcome back to the channel. Today we're breaking down how to write rational functions. We're going to cover step by step and cover any key features like asymptotes and holes. So let's go ahead and dive right in. So here are some strategies that you'll need when writing rational functions. So you always start with the zeros or the x-intercepts and your vertical asymptotes. If you have a hole, then you're going to have a repeated factor in both the numerator and denominator. And then apply what you know about horizontal asymptotes and the degrees of the numerator and the denominator. Consider the y-intercept if you are given it. And don't forget, because this is a function, you're going to write either y equals or an f of x equals. So here we go. We're going to go ahead and write a rational function. So we're going to start off with f of x, and a rational function should give you a fraction. So we're going to look at the vertical asymptote. X is -1, so vertical asymptotes should always be in the denominator. So the factor would be x plus 1. If you are given a 0, the zeros you always get from the numerator. So the 0 of 3 comes from x minus 3. And then the last thing that you would know is the horizontal asymptote of y is equal to 2, which means that your degrees are even Stevens, which means the degrees have to be the same. So right now the degrees are the same. It's an x of 1 and x of 1. But when we have the degrees the same, in order to get a value of 2, those are our lead coefficients of the numerator divided by the lead coefficient of the denominator. So you could put anything like 2 over 1, 4 over 2, anything that if you divide those two lead coefficients, it would get you the answer of y is equal to 2. So here is our first rational function equation. Okay, here's another example. We're starting off with, again, f of x. I'm going to make my little fraction line. We'll keep going with the vertical asymptotes as our starter here. You have a vertical asymptote at x is -2, so that would have come from the denominator, the factor of x plus 2. The next thing we're going to look at is our hole. The hole is at 3. So remember, you have a hole when you have a common factor. So that means you're going to get x minus 3 and x minus 3 in both the numerator and the denominator. And then your horizontal asymptote of y is equal to 1. We know that's even Stevens. So we have to look at our lead coefficients. And right now we have an x to the first and then an x to the second. So what we're going to do is we're going to just go ahead and make sure the degrees are the same. So we could make that a 2. And we want y is equal to 1. So you have 1 over 1. You could have, again, 2 over 2, 3 over 3. Okay, next example, rational function, starting off again with f of x. You have a 0 of -2 that would come from your numerator. So we're going to have x plus 2. We have a y-intercept of 5. So we know that when x is 0, then your y value is 5. So again, you could do anything like 5 over 1. You can have 10 over 2. So we could have like 10 over 2 here. When you have a horizontal asymptote of none, that means it is going to be top heavy. So right now your degree is a 1. I mean, the degree on the denominator is 0, so that one checks out. Okay, you have f of x fraction. Here you have 2 vertical asymptotes. So that would have come from x plus 2, x minus 2. You have a 0 of 4. That's from the numerator. So x minus 4. If you have a slant asymptote, that means the numerator is 1 degree larger than your denominator. So you're top heavy by 1. So right now you have a degree of 2. right? Because it's x times x, and then you have a degree of 1 in the numerator. So what you're going to do is we're going to make the numerator a degree of 3. All right, so that's how you write rational functions like a pro. If this helped you, give it a thumbs up and share it with a friend who's also studying math. If you have any questions or want me to cover other examples, drop a comment below. And if you want more videos like this, don't forget to subscribe and hit that bell so you don't miss any future lessons. Thanks for watching, and I'll see you in the next video.